All right, for those of you listening at home, that would be the people slaving away at the AP test and Michael. So, howdy.
And Michael.
Well,
We miss you too, Michael.
what. So, two things happening today. First, well, I guess three. First, we are finishing off the notes on finding equations, positive sign, positive cosine, negative cosine, if I give you the graph. Second, I'm going to give you an application problem for when we would actually use this in real life. And three, hopefully give you some time to work. First, notebook out. Look for beverage.
Do you like water, Mr. President?
I'm trying to hydrate.
Would you like it? Do you like water?
All right, sure. This doesn't make me forget that. Kind of a week. Okay. For example, suppose I gave you a graph like this. That would be rough.
Yeah, I'm surprised you want about people, Mr. Cochran.
Actually, allergy to water, there's technically, it's called rabies.
Yeah?
Yeah.
Yeah, I watched a YouTube video.
Another name for rabies is hydrophobia. This is all I'm going to tell you, and it's not much. I want you to extrapolate and give me, you don't have to give me all four, well actually, for now, just give me any equation for this thing whatsoever. So,
Wait, is this exactly symmetrical? Do you know the middle point is right in big seven?
yes. In sine and cosine, that's always going to be true, because it regularly, it goes at the exact same speed up and down, up and down. So yes, the minimum is always halfway between two maximums, and the maximum is always halfway between the minimum and so forth. And this middle point, where it hits the, where it hits the baseline, is exactly halfway between the max and min. So some things are nice in our favor. Did anybody tell me anything about this thing at all? Some of the numbers in here are a little weird, I'll warn you. What can you identify just by looking at the graph? Look carefully.
Where's the mid, or where's the base?
Incredibly good question. I do not know yet.
But why is there points at the base?
Good point. I'm hiding them to see if you can find them. With what? How do you get that? Look where the max is, look where the min is, and look halfway in between. How do you get halfway in between? There are two ways to do it, but there's a standard way. How do you get halfway in between any two numbers? Right, averaging. So in other words, the baseline, which is y equals, what is the max plus the min divided by 2. If they didn't give you the baseline, you can find it that way. In this case, it's 3 plus negative 2 over 2, or 1/2. The baseline is y equals 1/2. Which is a little weird. I'm going to mark that. So it's a little above 0. This is a 3, this is 0.5, and this is -2. Can anybody find the amplitude based on that? Anybody get the amplitude? It's a little strange.
Yeah.
It is 2.5, correct. They're not always whole numbers. In this case, it is not. The amplitude, since it's a nice decimal, I'll let it go as a decimal. So the amplitude is 2.5. Or if you like fractions, which I tend to do, 5 over 2. Yeah.
Period 7.
The period is 7. How do you get, well, almost. A period is how long it takes to go one complete cycle. I like the idea of 7. Is there a complete cycle on screen?
Yeah.
It is 14. How'd you get that?
Oh my gosh, sorry.
Right. It's the distance between 21 and 7. So the period is, they're all 7s. Okay. It's 21 minus 7, which is 14. Good. So the period is 14. What's the quarter period while we're at it? Not a whole number. Half of a half, was it? Yeah. What's half of 14? 7. Half of that?
702.
Yeah, 7/2. So the quarter period, and what's that as a decimal? Usually? Yeah, 3.5. So the quarter period is 3.5. It's rare that I do decimals, by the way, so enjoy this while it lasts. How long, this is actually going to work in our favor. How far over is it by the time it hits the baseline? How long is this little distance jump? Like, what's the distance from here to here?
Oh, would it be
How much did it move?
6.5?
A 6.5.
So it'd be 10.5.
Smaller. Go ahead. 3.5. Quarter period. This is the quarter period. From the max to the base is a quarter period.
But sorry, but when the point is 10.5?
Yes. Point is 10.5, correct. So where is this? Which they forgot to tell us, or forgot to tell us. How far over is this? Where is this location?
Oh, what?
How far over is this minimum?
14?
14. Thanks. How to get that? Add another 3.5. So where is the next baseline point?
17.
Exactly. 17.5. So everybody see how we got that? Once you get these, how big the intervals are, and you just divide by 4 from the period. And if it's a decimal, if it's a nice decimal, go ahead and use it. If it's not a nice decimal, like, something over 7, just use fraction. But we now have at least 5 points on the graph. We've got the baseline, we've got the amplitude, we've got the period and quarter period. What did we not yet find? What's missing? There's one more piece of info. Horizontal shift. Why have we not answered that yet? There's a good reason why we haven't. Where's the starting point?
We don't know.
Exactly, we don't know. Now, let me be a little more specific. Can somebody find a positive cosine equation for this? Can anybody give me the horizontal shift now? Yeah. 7, correct. This is a positive cosine starting point. Or you could use 21 if you're in the mood. So, I'm just going to put in parentheses h equals 7. You could just as easily.
Do you want just us to give you one for each?
Yes, just one. You do not have to give me both of them. Just pick your favorite. I'll do 7. Y equals, let's go piece by piece here. We need A, B, H, and K. Where does A come from? Sophie. Amplitude. What is the amplitude in this particular case? 2.5. If I'm doing a positive cosine graph, do I want positive 2.5 or negative 2.5? Exactly. Positive 2.5. Whatever kind of graph you want, make it that sign. You don't really have to put the plus, it's just, you know what I mean? Is it going to be a sine graph or a cosine graph? Sophie, one more thing. Cosine. Julia Cishon, take over. What letter goes here? I'm sorry? B. How do you find B? Question or answer?
Yeah, I have a question.
Yeah.
Shoot, what was the question? Oh, yeah, so can we choose whichever one we want
Yes.
for cosine? So
Yeah. When I'm grading the test, I write out all the possibilities so that if you use 7 or 21, either one's fine.
Well, I mean, like, why do you don't have to do positive cosine, right?
Oh,
We do-
you're going to have to do one of each. One positive sine graph, one
Oh.
positive cosine graph, one negative sine, one negative cosine.
Oh, yeah, yeah,
So give me one example of each.
Got it.
inside each category, you can pick whichever starting point works.
Got it.
So how do you find B? I don't see it up here. Do you remember from yesterday? It's a backwards version of a formula we already have. 2 pi over p, correct. P is 2 pi over b, and b is 2 pi over p. It actually does work that way. So let's do that. 2 pi over, what's the base? 14. So it is what? Got it. That's the value of b. So visualization, I'll take over. What would I put here? And while you're at it, x minus what? 7. How do you get that? That's the horizontal shift we're using. If you had chosen x equals 21, you would have done x minus 21. That would have been just as good. Plus what? No.
Sorry, did you say my name?
Yeah, I'm sorry, yeah.
Oh, okay.
I'm ruining this math.
Plus 1/2.
Yes. You wrote down the equation. Does that make sense? Why did we go through and mark all of these interior points? Now, if you have a maximum point, getting a positive cosine graph is really easy, because that's the starting point anyway. Can anybody give me a positive sine equation? To the left, take this one. Is there a positive sine starting point anywhere in there?
Yeah.
Whereabouts?
17.5.
Right. This is a positive sine starting. All right, we can use that. So h equals 17.5. Go for it. From beginning to end, y equals what?
Okay, y equals 2.5.
Yep.
Parentheses, pi over 7.
Before that, which function? Sine or cosine?
Sorry, sine.
Sine. Okay, and then parentheses what?
Pi over 7.
Correct, and that'll never change.
X minus 17.5.
Nice.
Plus 0.5.
Front plus 0.5. Done. Most of it stays the same. Yeah.
So for that one, could you like theoretically subtract the period from 17.5 so you get a smaller?
And find the earlier one? Yes. Am I right? How big is the period again? 14. If this is 17.5, you're basically looking for this one. Where is that? You can, exactly. That'll be a 3.5. You can mathematically find that. So if you did x minus 3.5, totally okay. Yeah.
Yeah, so I guess I'm confused about how we figure out what the horizontal shift is.
Oh, we do not have the horizontal shift until you pick a starting point.
Oh, so
So you manually pick a starting point. Make sure it's a correct starting point.
Right.
Like if we're doing a positive sign, make sure it's a positive sign starting point. Well, either one. If you start here, the horizontal shift is 3.5. If you start here, the horizontal shift is 17.5, and so on. Yeah, so we had to wait till the bitter end to fill in horizontal shift. Let me see. Pete, try this one. Can you give me a negative sine equation? Is there a negative sine starting point up there?
10.5.
Yeah, 10.5 is a decent one. I mean, if you're feeling exotic, you can always go forward or backward.
So
I told you about that yesterday, where there's this guy who was obsessed about, you would go like 8 million miles into the future, and then he would say, oh, 14 times some 7-digit number, and then add starting point. Anyway, moving on. Try it.
So you get y equals 2.5.
If it's a negative sign, use
equals -2.5.
good. Everybody see why? If you're using a negative sign equation, just start it with negative. That's all you have to do. And then go ahead.
Times sine.
Uh-huh.
Parentheses pi over 7.
Good, that'll never change.
X minus 10.5.
Good.
And then plus 0.5.
Right. And you notice the number at the end never changes. That's the baseline. The baseline is the same no matter what equation you use. So good question.
So the only two things that would change would be the horizontal shifts, and if the thing is positive and negative anything.
Yeah, there are technically 3 things that'll change. They're all kind of obvious. The horizontal shift will change. That's the most important. Then yes, the plus or minus in front will change, and whether it's sine or cosine will change. But yes, everything else will stay the same. The actual number in front will stay the same. The value of b will stay the same, and the baseline will stay the same. So a lot will stay the same. You just have to tweak the stuff that changes based on the starting point. There's one more equation we need. Can somebody give me a negative cosine equation? Julie Miller, try this one.
Y equals negative 2.5.
Yep.
Cosine.
Cosine.
Parentheses. Pi over 7, parentheses, x minus 14, parentheses, plus 0.5.
Yep. That's the assignment. Make sense?
Yeah.
Think you can do that? I'm gonna give you just a teaser, and this is only gonna be like 5 minutes. Tomorrow, brace yourselves. The notes are gonna be intense. It's, once you get used to it, it's actually rather fun. But the first time you see it, it really makes people's eyes bug out of their head. Here is an example. It's gonna be a bunch of words, so write it down as best you can. Pebble Beach has high tides of 13.2 feet, comma. Low tides of 7.2 feet. Something like that. I'm trying to splice out all the words you don't really need.
Is Pebble Beach a real place?
I just made it up. I'm sure there is a pebble, there's lots of pebble beaches somewhere, but I just made it up. So our fictitious Pebble Beach has high tides of 13.2 feet. So like they put a measuring rod out, and on that, you're familiar with tides, like they're basically from the gravitational pull of the moon and the sun. And so basically the sun and the moon are basically pulling the water further to shore whenever it's in the right position. And then when the moon moves away, or when the earth rotates, the water is received back down. And it goes up and down and up and down, and it's predictable. You can pretty much predict where the tide is going to be at any given day, point of the day. Now, on May 11th, 2021, they had the following. The first low tide was at 3:30 a.m. The first high tide was at 11 a.m. Find an equation for the height of the tide at x hours, where x is the number of hours after 12 midnight. On May 11th, 2021. Once you get an equation for the tides, then you can predict, as long as the tides stay constant. They sort of do. In real life, they're a little more complicated because the sun and the moon move differently, and they'll sort of wibble wobble a little bit strangely, but they're relatively predictable. And for the purposes of this problem, we're going to assume it's like clockwork. It's going to go up and down the exact same amount. So, does it make sense that this would look like a sine graph? It's going to go smoothly up, smoothly down, smoothly up, smoothly down. Can everybody tell me where the maximum is? Just for looking at the problem. 13.2. That's the highest tide. That's the maximum of your graph. What's the minimum? can you find the baseline? Sophie, help me out. How do you find the baseline if all you have is the max and min? Exactly, average them. So the baseline, y equals 13.2 plus 7.2 divided by 2. Go ahead and do it. Okay? 10.2. That is your baseline, which you will need for your equation. Does that kind of make sense? We've actually got about a third of the way done with our problem. We know that it's going to be wibble wobbling between 7.2 and 13.2, and that the baseline is 10.2. Starting point. What is the very first event that they talk about? Like, what is 0? What's time 0? Like, x is the number of hours. Since when? Midnight. That means the very start of the graph is 12 midnight on May 11th, 2021. So you notice this is a little bit annoying, but we human beings count in hours and minutes. Computers do not. Computers, well, they don't count at all because they can't think, but they largely count in decimals. They don't care what time of day it is, they care how many hours have gone by. If you ask a computer, how many hours have gone by? 0.6 hours have gone by. What's that for us? 0.6 hours. We don't like 0.6 hours, we like hours and minutes. Can somebody tell me what 0.6 hours is in minutes? How many minutes are an hour? 60.
35.
Close, very close. 0.6 hours. 0.6 hours.
Oh, it's 36.
Uh-huh. How'd you get that?
Well, you know, there are 60 minutes in an hour, 10% of that is 6, so you just do it 60 times.
Right, exactly. 0.6 hours is really 0.6 times 60 minutes. An hour is the same. You can just replace hour with 60 minutes. 0.6 times 60 is 36.0 minutes. That's how we measure time. The computer does not care how many minutes there are. The computer wants to know how many hours there are. Look at 3:30. If you mark this and say 3:30 a.m., that's good for us. That's good for humans. But the computer will not know how to do it, to handle that. The computer wants to know how many hours it's been. You tell me. Since midnight. What's that? 3.5. We're going to say x equals 3.5. That's this. That's what the computer is going to use. Can somebody give me the next event? Pete. This is 3.5. That's the low tide?
So, high tide would be at, would it be x equals 11?
X equals 11, which is kind of nice. So this is 11. So it's 11 a.m. means 11 hours have gone by. In real life, this would usually be something rather strange, like 8:24 a.m. And you'd have to figure out how many hours that is. It's like 8 point something. And then 24 minutes is how many hours? I don't know. Multiply that. But does everybody see? Where would I put a dot at 3.5? What's that? Yeah, it's 7.2. It's a low tide. It's at the minimum. And where would I put a dot at 11? High tide. Does it make sense that it's going to go smoothly up like this? I'm just going to keep going. Can somebody find this point for me? Use that trick we used in the previous problem. How far in is that point? Like what fraction?
7.1.
How do you get it?
11 plus 3.2, or 2.5.
Yeah.
7.25.
7.25, got it. Got it. I wanted to say got it and good, and it did not. So yeah, take the average of the two, it's halfway in between. What kind of a starting point is that? That I just circled?
What's the positive sign?
That's a positive sign. What kind of starting point is this?
Positive cosine?
Positive cosine, up or down here on the left.
Negative cosine?
Mhm. Now, the nice thing about a problem like this is they don't care whether you do a sine equation or a cosine equation. Pick whichever one is easiest. I would probably pick a cosine equation, just because I don't even have to find this point in the middle. Unless they ask me to. So can somebody tell me, is there a complete period on screen? No. How much of a period is there? Give me a signal.
Quarter?
Sort of.
What is half?
There's half. This is 1/2 of a period. 1/2 period. And how long is that? How many hours is it? From 3.5 hours to 11 hours. 7.5. If a half period is 7.5, what's a full period? 15. That's useful. Can somebody find B for me here?
2.5 with the 15.
Yep. And I would leave it like that because it doesn't reduce. Can somebody give me the equation of this whole thing? By the way, you pick. Do you want cosine or sine? It doesn't matter.
Sign.
Sine? Okay. Positive or negative sign?
Positive.
Yeah, I don't blame you. If you did negative sign, you'd have to go and find this point, or this one. This one's already sitting there. So, positive sign graph, y equals what? Oh, we need to find something. Amplitude, can we do it for me? 3. By the way, you're welcome. No, man, it's like 2.7 or something. So, go ahead, y equals what?
3.
3.
Sorry, 3 sign.
Sine.
Parentheses. 2 pi over 15.
Yep. 2 pi over 15, parentheses,
X minus 7.25.
7.25.
Oh.
Prime.
Plus 10.2.
Done. Now, what I'm going to ask you to do once you, that's the hard work, by the way. Well, part of the hard work. Then I'm going to start asking you questions saying, give me the height of the tide at 7 p.m. on that day. Can you tell me what that would involve? How would you answer a question like that? Like, here's your equation. Ta-da.
So 7 p.m.?
7 p.m. Correct. How would you do that? Like, if our main thing is to predict the height of the tide at 7 p.m., let's just say we want to go, rafting or something, and if the tide goes out, we're going to be left stranded. And I want to make sure it's not the low tide. I want to know the height of the tide at 7 p.m., because that's when the party is going to be, the rafting party. So, how do you do it? And let's assume it's the same day, May 11th, tonight.
You add the period?
Maybe. How many hours into the experiment is 7 p.m.? I think that's
19.
How do you get 19?
You do 12.
Yeah, the morning is the AM, that's 12, and then it's 7 p.m., so an extra 7 hours. So if it's 7 p.m., it's 7 plus the 12 from the morning, it's 19. Guess what you do with that 19? Plug it in. You'll need a calculator for that. So I'm going to leave that right now, but we have this videotape.
Homework is?
This is not your homework is for tonight.
Oh.
This is what your homework is for the next day. For tonight, it's actually not all that big. There are 3 problems. You will have to get 12 equations,
12 questions?
1 of each.
Oh.
So 4 for the first, 4 for the second, 4 for the third. 1 positive sign, 1 negative sign, 1 positive cosine, 1 negative cosine. Okay, no problem. And then this is a teaser of the, what I call the tide problems, which are an application of this stuff. Just so you know, these questions can get pretty involved. One of the questions I ask is, can you predict the tide on September 10th, 2022? You will have to find the number of hours since midnight on the 11th till October 10th, 2022. It is possible. It's a little tedious, but it's possible.
Mr. Cochran,
Yes, ma'am.
are we for sure that all of these dots, or some of them, hit a whole number?
They do, some of them look like they hit a whole number and some,
Like, how can we figure that out?
okay. I can tell you right now that the maxes and the mins definitely hit a whole number.
Okay, yeah, that's what I was wondering.
Yes. You know, all three of them, maxes and mins, hit a whole number. Now, or at least at a line. Yeah, the in-between ones, maybe, maybe not. You know where it looks like it hits at 8, the number 1?
Yeah.
It does not. It's a little bit less than that. So the rest of it's yours. People listening at home, God bless, I'll see you later. And I think I already emailed it. Well, if I didn't email you already, I will soon. So take care. Bye.